Lecture 12, the normal distribution. Now, in this lecture, we will learn how to identify the properties. So we will identify the properties of normal distribution and how to use 68, 95, 99 rules and find the probabilities using the standard normal distribution and apply the normal distribution for solving problems. Look at this histogram. This is a histogram from the real life data, and it has a normal distribution. So this shape is called normal distribution. So here you can take this as the x variable, and in a histogram, the y-axis is for the frequencies. So, for example, this might be the exam score distribution. Like these are the f. I mean, this one is F, this is A, this is the middle is B, C. Sorry. You expect, the number of students who got F, who got A, same, and you have more students on C. Now, from this type of, these distributions are, I mean, we call them normal distribution. So with this shape here, and in the real life, we always face this type of distributions. And now we changed, after doing some mathematics, we can make this one a pure mathematical curve, and this curve is normal curve, and x will be just a random variable here, and this type of distribution we'll call it continuous probability distribution, and if it has this shape particularly, it's called normal distribution. So a normal distribution for us is a continuous probability distribution for a random variable x. And these, I mean, the y-axis here, it's not the frequency, by the way. I told you there's some more mathematics in it here. Changing this one to the probability distribution, there's more math. And we will see that the area here under the curve is corresponding to the percentage or the probability for x. Show you the very important facts about the normal distribution and continuous probability distributions in general. These are very, very important things, so you have to keep them always in your mind. Now, the first thing is, in a continuous probability distribution, the area under the curve corresponds to the probability or the percentage of data. Now, this area here is giving you the probability or the percentage. So the total area here, the total area is in terms of probability. As probability, you can say it's 1. It's 1. Or you can say the total probability, total percentage of the data is 100%. So in some questions, we will ask the percentage of the data fallen between two numbers or more than this. Sometimes we will say the percentage, or sometimes we say the probability that, the x is between 1 and 2, as an example, I'm saying it's 100% here. So the area here is important. The area under the curve makes the probability or the percentage of data, and the total area is always 1 or 100%. They're same. So the area, the second important thing is the area under the curve on a certain interval a b is equal to the probability that x is between a and b. So this area here, this area is equal to, either you can say this is the corresponding to the probability that x is between a and b, or you can say the same thing. You can say here the percentage of the x values, the percentage of it also corresponds to percentage of x values or data that are between a and b. So you know, from question to question, it will change. Like sometimes we say, what's the percentage, or we directly say, what's the probability that X is between A and B? So depending on the question. And the other thing is the probability that X is equal to a number is 0, because the area of a line is 0. So when you look at here, so what's the probability that X equal to C? If it has a normal distribution, if X is a normal distribution, then we say it's 0, because we look at the area here on this line. The area on a line is 0. So for this reason, it's not two-dimensional, so it will be 0. So we say the probability that X equal to C is 0 if X has a continuous probability distribution, and in our case, if it is normal distribution. Let's look at the properties of normal distribution in detail. Now, let mu be the mean of X and sigma be the standard deviation of X. X is a random variable, so X might be this exam score, or age, or something like that. If X is normally distributed continuous variable, then we write X tilde n mu sigma. So when you see this notation, it means X is normally distributed. One thing, the first thing is this one, and the second thing is that its mean is mu, and the sigma is the standard deviation of X. So if X has a normal distribution with, let's say, 0, 1, it means its mean of X is 0, and the standard deviation of X is 1. Okay, so it might be some other number here, 2, 3, 4. I just gave you the example 0 and 1. Now the other properties. Okay, now we'll talk about the shape of, mostly shape of normal distribution. So here this is X, and it has a normal distribution, as you see, and mu, where is this mu? You can see it here at the center. So mu is the mean of X, and it's at the center of the curve. Now in a normal distribution, the mean, median, and the mode are equal and located at the center of the distribution. So this is mean, we know it, and then it's equal to also the median, and it's equal to also the mode. And the normal curve is bell-shaped and symmetric about the mean. As you see, it's very clear that it's bell-shaped and it's symmetric. The normal distribution is unimodal. Unimodal means it has only one mode, so it means it has only one hump. So it's not like this, it's not two humps, it's only one hump. So here it's unimodal. This is unimodal, and this is called here what is not unimodal, it's bimodal. For example, this is bimodal because it has two modes. So we don't have it here in the normal distribution. It's unimodal. It means it has only one top and one hump, let's say. And the total area under the curve is equal to 1. So we already know that this is just 1 here, or in terms of percentage, it's just 100%. The normal curve approaches but never touches the x-axis, and it extends farther away from the mean. So this is okay. The graph is not very exact. It's not exact. It looks good, but it's not exact. Indeed, in the graph, you see it's touching the x-axis, but this is not true. This here, the curve here does not touch the x-axis, but it gets closer and closer here. So it says it's never this curves here never touches the x-axis, never touches the x-axis. So then you can say it goes to infinity by decreasing. It never touches the x-axis, but it decreases by the time. The x-axis, yeah, it never touches the x-axis. And this is same as this part here. Same in this part. And one other thing is after this one. Okay. One other property is this between mu minus sigma and mu plus sigma. So it means, okay, mu plus sigma. So what is this sigma? Sigma is the standard deviation, just a number. So after, up to mu plus sigma, and from mu minus sigma to mu plus sigma, the, okay, let's make it this one here. Okay. Now up to here, between these two values, this shape here, you see, it's looking down. But when you look at this part here, this part, it's looking upward here. So these parts here, this part is looking upward, and this part is looking downward here, between mu minus sigma and mu plus sigma. And this part here, after mu minus sigma or before mu minus sigma, it's looking up. So in mathematics, we say it's concave or concave up or concave down, or we say convex up, convex down. But here the important thing is this behavior of change is starting at mu minus sigma and mu plus sigma. So, and these points, the points at which the curve changes from curving upward to curving downward, called the inflection points here. These points are called inflection points. Now in the next slide, you will see clearly the inflection. What are the inflection points? We will show them. Now we will look at some other details about the normal distribution. Now let's assume this x here, it has a normal distribution, and its mean is mu and its standard deviation is sigma. And its graph here, the distribution or the normal curve of x, will look like exactly this one. And let's see, let's look at these numbers here. This mu is just the center and its mean, and mu plus sigma is here, and mu plus 2 sigma, and mu plus 3 sigma. And of course, the curve continues here. It never touches the x-axis, but still it's approaching the x-axis, and it behaves the same way here. So if you want to keep writing like mu minus 4 sigma and the other stuff, you can, of course. But these three of them are important for us. Okay, these like sigma, 2 sigma, and 3 sigma, are they? They are important. One reason for this is the normal curve exactly behaves like this. This part here, this total area, is almost like up to between mu plus 3 sigma and mu minus 3 sigma. It's almost 1, so it means like it's 0.997. The rest here, it's very, very, very small. It's their total is in terms of area, it's 0.003. And let's look at these. These points are the inflection points because the behavior of the curve is changing from, look, it's now looking down here, but here it's looking up. Here it's looking down, and here this is looking up. And if someone wants to know about this curve, mathematically, what its formula, most curves has a explicit mathematical formula in terms of x and y. So this is the mathematical formula of such curve. If you want to do it with a graphing calculator or on a website, so you can put this numbers here, put mu something and sigma something, and try to graph it, you will get a curve like this. And we give you only mu minus 3 sigma, mu minus 2 sigma, mu minus sigma, and these values here are significant. The rest generally we don't need to look at the area. The area is very, very small. But of course, we will deal with this part, of course. We will not let it go. Okay, these are the important things. These are the important points you have to pay attention to in a normal distribution. we know how a normal distribution look like, but I mean, all distributions, they look the same way, but there are differences between them. Let's look at these two examples here. Um, Now, let's look at these two graphs here. These are both normal distributions, but when you look at them, one of them is centered at 3.5, which is mean, and the other one is centered at 6. And their standard deviations are like 1.3 and the other one's 1.9. So what's the difference between them? It's the thickness here. So as you see, we can say not thickness, maybe the spread of the data here. So on the right side on this graph, the spread is definitely bigger than it has more spread. The data is more spread to the right and left, but on this graph, it doesn't spread as much as the other one. So it means more standard deviation means more spread of data. So as you see here, so we say standard deviation describes just the spread of data, but mean just shows the center. Now let's look at this example. Which curve has the greater mean and which curve has the greatest standard deviation? Now, when we compare the centers here, center means the means. So of course, B has a greater mean for sure because it's at 9, so its mean is 9. And when you look at the standard deviations, you look at the spread, which data is more spread. So definitely this data is more spread to the sides towards the left and right. But A looks more concentrated on around the center. So B has a bigger standard deviation in this case. Now we will learn a rule about the area under the curve. And assume we have a normal distribution or we have a random variable or variable which is normal distribution with mean, mu, and sigma. In this case, the approximately 68% of the data or the x values fall in within one standard deviation of the mean. What does this mean? It means the probability that x or the percentage of the x values between mu plus sigma and mu minus sigma is 0.68. And 95% of the data or the x values fall within two standard deviation of the mean. Means also this, the probability that the x values, the probability that x values or the percentage of the x values that are between mu minus 2 sigma and mu plus 2 sigma is 0.925. And we have another rule for 3 standard deviations. So it is this, the percentage or the probability of the x values between mu minus 3 sigma and mu plus 3 sigma is 0.997. So you can say 99.7%. So what does this correspond to? It corresponds to areas here. So when x is between mu minus sigma and mu plus sigma, so you say 68% of the data here is between mu minus sigma and mu plus sigma. And in the same way, when you look at the area between mu minus 2 sigma and mu plus 2 sigma, this part becomes 95, 0.95. And when you look at the area under the curve between mu minus 3 sigma and mu plus 3 sigma, this whole thing becomes, this area becomes 0.997. And you can ask these questions, these numbers, where do they come from? If you do calculations, you will get them. Okay, this here, it says 13. Maybe the exact number is 13, but approximately this is like 68%. So if you divide them into 2, you will get 34, 34. And this part, we know this part is 95. So what you can do here to get these, you can subtract 95 minus 0.68, divide by 2. then you will get this part. By doing this again with 99.7, 95, and 68, you can also get all these percentages here. So for each part you can calculate them. Let's look at this example. Now, IQ test scores and the results of many other standard tests are designed to be normally distributed with mean 100 and standard deviation 15. Find the data that is within 1, 2, and 3 standard deviations of the mean using 68%, 95%, and 99.7% rule. Now, it says IQ tests and the other tests are normally distributed with mean 100 and standard deviation 15. So here you can say this X is IQ scores, and X has a normal distribution with mean 100, this is the mean, and standard deviation 15. So in this case, what can we say about the data within 1, 2, and 3 standard deviations of the mean? So let's remember the rule. The rule says 68% of the data is, or the exam scores are between mu minus sigma and mu plus sigma. So here our sigma is the standard deviation, which is 15. Now mu is 100, so sigma is 15. So you can say the same thing here. The exam 68% of the data between 100 minus 15 and 100 plus 15. So we can say 68% of data or the exam scores are between 85 and 115. Now, if you remember the 95 rule, for the 95 rule, I will change this one, 95, and it will make 2 sigma here, and it will be 2 times 25, 15, 2 times 15. And you can do the same thing for 99.7%. So here is what we get at the end. So this is now clearly written here. Yeah, so as you see, it's 68% of data between 65, okay, 85. So I will say here 85, and 115, and 95 is 70 and 130. These are mu minus sigma and mu plus sigma. Mu, yes. And then here is the normal curve, corresponding normal curve here, normal distribution here. So 100 is the mean here. Then mu plus sigma, mu minus sigma, mu plus 2 sigma is 230, and this is 70, sorry. And then this one is mu plus 3 sigma. So mu minus 3 sigma and mu plus 3 sigma here. And these are the things we got from the 68%, 95, and 99.7 rule. Let's look at this example. If the student scores in statistics is approximately follow a normal distribution with mean 70 and standard deviation 5. Find a proportion of students who scored within 1, 2, or 3 standard deviations of the mean using 68%, 95, and 99.7% rule. The proportion here means you can say the percentage, you can take it as a percentage. So it's asking the percentage. And B is asking the same, almost same, but the percentage again, percentage of students who score more than 80 using 68, 95, and 99.7 rule. Now, the first part, it says directly use the rule. Okay, first let's write 68 rule. What does it say? 60. So what does this mean? 68% of the students, okay, or the test scores uh, are between mu minus sigma and mu plus sigma. You know, it's just normal distributed, so you can say test scores are, and they have a normal distribution with mean 70 and standard deviation 5. So mu is 70 here, and sigma is 5. So you can say you're 70 minus 5, and this is 70 plus 5. And you can write here, this one will be 65, and the other one will be 75. So we can say 68% of the students scored between 65 and 75. And you can do the same thing for 9 to 5 rule. You can apply this for mu minus 2 sigma and mu plus 2 sigma. And for the 99.7 rule, so you can use 3 sigma. So we get this one then. I mean here, for this one, we have these scores. And let's come to the part B. So find the proportion of the students who score more than 80 by using these rules. Now here, where is 80 here? So 80. So let's try to, do it with the area under the curve. Now this is mean, this is 70, and then 75 is here, and then 65 is here, and then 80 is here, and then 60 is here, and we can do more here. We can do more. Okay, that's enough, I guess. So this part here, we know. So it's asking what this is. Find the proportion of the students who score more than 80. So it's asking which region. So it says the percentage of students who scored more than 80. So more than 80 means here this region here, right? More than 80. So we want to find the area of this part. So the question is, how can we get this part? Now, what we know about the area for now is this part here makes between 80 and 60. It's the 95% of the students are here. So the percentage here, so I will say this part is making 95%. This makes the 95% here. So if these two parts here, the green parts, since it's a symmetric, normal distribution is a symmetric distribution, so they are same. This part, the green parts are same. The green parts have the same area. So They have the same area, so how can we find it? So basically, the green parts here will be the green parts is equal to 1 minus 0.95. So this will give you 0.05. And then we want this part only because it's symmetric, so they have the same part, they have the same measure of probability or the percentage. So we will divide this one, only this part here, then this part will be 0.05 divided by 2 because both green parts, two green parts will 0 is 0.05, and when you divide this one you will get 0.025. So if you convert this one to percentage, it will be just 2.5%. So this will be 2.5%. So you can use this idea here because if it is 95, remove 95 part, you will get 5% part. 5% part will be, okay, you will get 5% part, so you will divide the 5% by 2, and this will make the red part here, which is 2%. So the answer is, final answer is the percentage of students who scored more than 80 is 2.5%. Standard normal distribution is a special distribution, and it has this property. The standard normal distribution is a normal distribution with mean 0, and the standard deviation is 1. And its variable is most of the time where we use z for it. So you can say z has a normal distribution with mean 0 and standard deviation 1. So in this case, when you see this one and 0, 1, it means it's standard normal distribution. And it's a quite useful normal distribution. It's the advantage of using it is the all normal distribution can be converted to the standard normal distribution by subtracting the mean and dividing the standard deviation. So assume x is a variable with normal distribution with mu its mean and then standard deviation sigma. Then using this conversion, you can define x minus mu divided by sigma as z. So if you do this conversion, and then your z, the new variable z, will have a normal distribution, standard normal distribution. And the good thing about this one here is the area under that curve, the area under that curve, under this distribution is calculated, and the tables are a normal standard normal distribution table is prepared so that we can change this. Any question here about x can be changed to a question to z, and then we can use a table and we can use the probability or the percentage. Okay, before using the standard table, let's understand the notation for the areas. So area under the standard curve, so we will look at the different cases in finding the area under the standard normal curve. So which notations mean which area, so we will see. And here, since we are using the standard normal distribution, we are dealing with z here. Z, big Z, is has a standard normal distribution, so it means it's normally distributed with mean 0 and standard deviation 1. Now, when you see this notation, you will understand we are talking about this area here. So big Z is showing us the variable. Little z is just a number here. So the probability that z, or the percentage that z, big Z, is less than z means this part here, because all the big Z values here are less than little z. So it's showing you this area. So it means this notation here, the probability or the percentage big Z is less than little z means the area of the left of little z. Now in the same way, the probability that big Z is bigger than little z, so little z is here and big Z is the variable here, and big Z is bigger than Z means here big Z, when you take the Z values here, they have to on the right side of little z. Now this is corresponding to the area, so the area to the right, but how can you find the area to the right? So since the total is 1, so you can say 1 minus this part here, left part, and if you are given, okay, if you see this type of notation, PZ1 less than big Z, which is less than Z2, and let's say this is Z1 here and this is Z2, and big Z is just a variable here. Now we're talking about this area. How can you find this area? You can find area to the left here first, and then you will look at the area to the left of Z1, and then you subtract them, and you will get the area. Now after this, we can now start using the table and calculate the probabilities or the percentages by the help of the table. Now we will learn how to calculate the probability Z less than something, Z bigger than something, or Z is between two numbers. And here our Z has a standard normal distribution, so it means NC has normal distributed, so with standard normal distribution, so mean is 0 and 1, the standard deviation is 1. And for this reason, okay, we don't use a calculator, or we can use a computer software, of course, but we generally use a standard normal cumulative probability table for this distribution. Now in this table, so we will learn how to use it, and there's a graph here. As you know, this area here is corresponding to a probability or the percentage of the data for some specific region. Now big Z here is our variable, and here this little z is here, and the little z is also, you see it here. So this area, as you know, the area is corresponding to, okay, it's corresponding to the probability that the variable z is less than little z. Z is just a number. Okay, and this area, or the probability that big Z is less than little z is calculated in here. So these are all the areas here. So these are all corresponding to the area under the curve. These are the area under the curve. Now we will learn how to use it in example. Now let's look at our first example. So the probability that Z is less than, let's say, 0.51. Now in this case, you have to find this this little z is now 0.51. Now you have to find 51 here, 0.51. So how can you find it? Now for the little z, this is big Z, by the way, this is big Z. Okay, for the little z here, you have to check the first column. I mean the first column, sorry, the first column first and the first row. Now these numbers are showing you the breakdown of this number. So it's the first one is 0.5, and you can write this one, the second one here, 1 as 0.01. So in this case, 0.5, the first column shows the first part of the first component of the little z, this is 0.5, and the second part here is 0.01. So you find these two, and after finding them, you will find the corresponding area. So the corresponding area is 0.6950, so it will be 0.6950. Now let's do some more examples. What about the probability that z is less than or equal to 0.5? So in this case, 0.5, we have to find this little z here. I mean, this is big Z, of course. A little z, where is this? 0.5. We know its first component is 0.5. The second component is what? So you can take this one as 0.50. So it has two components here, 0.5 and 0.001. I mean 000. So in this case, 0.5 is here, the first one, and the second one is here. So this number is corresponding to them. So you say the probability then, it will be 69.15. Now let's look at another one here. What's the probability that z is this? Okay, let's do another one here. Z is less than, let's say, 0. So what is this equal to? Now with 0, you can write 0 as 0.00. In this case, the first part will be 0.0 and the second part will be 0.0. So you see it's 0.5. Is this a surprise? No, it was just very expected one, because 0.5, if you think, we have this 0 here, so we're asking you to find the area, and when the total area is 1, so the half of it will be 0.5. And it is clear also from the graph. Now let's try to find so the other direction. So the probability that z is bigger than, let's say, bigger than 0.34. Let's not say this. Okay, let's say bigger than 1.39. So in this case, this probability is asking you to find, okay, if it is 1.39, okay, this is asking you to find this part of the graph. So, but be careful here. The table always shows, the table here shows this part. I mean, only left part. So when you look at here, it always shows this, but this one is asking you the right part. But this table is giving you the left part. Now, so for this reason, what you have to do is, I mean, you can do this way. You can write here 1. Okay, the total area will be 1, and it's asking the right part. So the best thing is to subtract the left part from 1. So left part will be this one, 1.39. Probability that z is less than 1.39. So in this case, we will find this part from the table, it's 1.39, and then we will subtract it from 1, so we will get this part. So the table shows us, okay, the table will give us this value. Where is it? It's 1.39, it's 1.3. Let's find, and this is the 9 here, this is 9, so it has to be 0.09. So it goes this way. Okay, we find the corresponding area. This is 0.9 to 177. So you can write here this one as 0.9 to 177. Now when you subtract this one, I mean, if you do the subtraction, I think it will be like 23 here, then there will be an 8 here, there will be another 8 here. No, it's not 8, sorry. It has to be, I think, 0.823, I guess. Is it? No, it's one more 0 here. So it has to be, so the probability that z is bigger than 1.39 is found to be 0.0823. Now, let's give you another example. This time z is between two values. So how can we do it? Okay. So here, let's do it this way. Okay. Now, what about the probability that z is less than 1, okay, less than 2.1, let's say. Okay, I will not choose 2.1. 2.1 is somewhere here, so I don't have it on my table, but I cut the table because it will not fit here. So you will have the big table. So this is a small table, by the way. This is a table which is cut. Okay, a cut. This is a table, a cut table. So let's say this is 1.5, and so let's not say 1.3. Okay, and it's 1.21. Okay, what's the probability that z is bigger than 1.21 and less than 1.3? So it's in this case, it's better you visualize it. So it's which area does it want? So 1.21 is here. Sorry, it has to be somewhere on the right side. 1.21 is 1.3. So asking this part only. So what can you do here? In this case, you find this area which is corresponding to the probability that z is less than 1.3 minus, okay, this area, and it will be the probability that z is less than 1.21. So you can write this way. I mean, now we can find the area and we can use the table here. 1.3 and it will be 1.3, but what about here? So 1.3 is 0 here, so for this reason it will be 0. The second component will be 0.00. It's 9032. It's 0.9032, and then minus. Okay, let's look at 1.21. 1.21 is, where is it? That's 1 point. Okay, 1.21 means 1.2, and 1 is here, so we are finding this value here, 0.8869. Now this will be, okay, if you do this calculation, you will get something like, okay, you can use a calculator for this. I mean, I can direct, I mean, I don't know, I mean, I don't want to spend time, but let's do it. Okay, it will be 3, and then here that will be 6, and it will be here, when it's 9, it will be, okay, it will be 0, so it will be 0 point, okay, it will be 0.0163. Okay, in the next slide, we will do the same thing with the negative numbers. Now we will do the same things, but this time I want to show you the table for the negative values. This time z is, the little z is here, so our variable is big Z, and we have a similar table in this case, but z is here less than 0, and the area corresponding to the big Z is little less than little z. And this area here on the left side is these numbers here, depending on the value of z. Now let's do some examples, but this time we chose the negative numbers. So for the negative numbers, we have another table. Okay, so these numbers are not limited to those. We have more, but I cut it for this. I mean, we cannot see all of them here, so I cut it from here. So let's do some example here. What's the probability that z is less than minus 0.0163? Okay, I will choose a number here. It will be negative 2.85. Okay, what is this? Now you have to look, the first component is here negative 2.8, and the second component here is from here you can directly say it's 0.05. So then you will find the corresponding number for them. This is negative 2.8 and 0.05 is here. So it will be just this one. So this will be 0.0022. Now, okay, so what about this? Okay, what about this? The probability that z is bigger than minus 2.85. You know, this time this type of question is asking this part of the graph. So how can you find it? Yeah, basically you calculate the area. Okay, you can write it this way: 1 minus the probability of the left part. The left part means this one here, the probability z is less than negative 2.85, which is 1 minus, okay, we found it here, it's here, so it will be 0.022, which is equal to negative 978, I guess. Yeah, it's, and there's always positive. Okay, a probability is always positive. Okay, if you get a probability which is negative, so it means you're doing something wrong. Now let's do another one. Okay, I will write here, this is equal to 0. Okay, it's 0.9. So okay, 0.0. So I made a mistake. It has to be 978. No, it's 99. Okay, sorry guys. 99. It's 99. I made a mistake here. Okay, and let's look at this one here. The probability that z is, let's say z is bigger than some number, a negative number, let's say negative, let's say, okay, I have to choose a number here, so I'll say 2.9 and less than negative 2.53. Okay, again, since I have a double-sided inequality, I will write this way: it's z less than, this is the probability of z less than negative 2.53 minus the probability that z less than, okay, z bigger than minus, no, of course, it's z less than negative 2.9. Now we will find this one here, negative 2.53, negative 2.5 is here, 3 is here, so we'll get this one 0.057. 0.057 minus, okay, we will look at this one here, negative 2.9, but there's no third digit here, so it will be just 0, 0. So look at this one here, this is, okay, corresponding to 0.019. Yes, it's 19 here, yes, minus 0.0019. So when you subtract this one, you will get 0.0038. So this will be the probability corresponding to this interval. Now the idea is here is same as before. So if someone asks you about a double-sided interval, the idea is you want to find this area. So for this reason, you want to find this part and then remove this part. So you subtract and you will get this part. So what we do here is this one here. So I think now the table is clear, but what if you have a question like this? Okay, now let's change the question. Now, if we ask you the question this way, what happens? The probability that z is less than 1 and this one is less than minus 0.5, let's say. So in this case, this one, you use the negative table. For this part, you use the positive table and do the same thing. So subtract um, less than 1 minus p, z less than negative 0.5. And for this one, you can use the table here, but for this one, you have to go with the positive table. So look at the positive table. In the questions, we will give you the positive table. I mean, in the exam, you will have it. Here, I want to give you a reminder. Um, we already said that, but I want to remind it again. So in a continuous random variable, so if you have a continuous distribution here, like this one, so as we know, these are the areas. So this is an area, okay, this is an area, and this is an area. So we look at the area. So here, equal to, being equal to does not change the area, because equal to means x equal to z means, or a means, it makes a line, and the line here has zero area. If it is zero area, so in this case, adding here a included or not, that will not change the probability. So for this reason, if you are dealing with a continuous random variable, having an equality in the inequality or not, a strict inequality or not, will not change the probability. So having this equal sign here or without equal sign, nothing changes. You will do the same thing as before. Look at here, they're all same. They're all same, because an area, including a number, doesn't add to the area. Now let's look at this example. It says find the area to the left of z equal to 1.23. So which means the probability that z, big Z, is less than 1.23. So on the graph, so we can see it's asking left side of 1.23. So we can use the table here. Our table always shows the left part of it. So left part of the graph, and 1.23, it's 1.3, 1.2 is here. So you can break this into two pieces, 1.2 and the other part is 0.03, and then it will give us this one. So when you find the corresponding number, you will get the probability that you will get 0.7907. So which is where we got what we get here. Now let's do another example here. What's the area to the left of z 1.51 in a standard normal curve? So it's basically asking, okay, we have to use the table, and it's asking this part here, left part 1.51. It's here. The center is 0, as you know, so it has to be something like this. So it's asking the left part. What we have to do is just find 1.5 here, okay, because 1.51 makes two components here. The first part 1.5 and the other part is 0.001, and then you will find this one, and it corresponds to that number here. So you can directly say the probability is the area to the left of z equal to 1.51 is 0.9345. Now find the area under the normal curve to the left of z equal to negative 0.99. So in this case, it's asking left part. Okay, this is 0 center, always the center is 0. They're asking the left part of negative 0.99. So it's asking PZ less than negative 0.99. So since we have a negative number, so we will use the negative part of the table. Okay, let's use the standard normal table. Okay, one thing here is important. When using the table here, we'll break it into two components here, negative 0.99. So when you write the components here, the first one is 0.9, negative 0.9, but the second one is 0.09. So you have to find the 0.9 and negative 0.9 and 0.09 and find the corresponding number here. So this will be the area under the standard normal curve to the left of z equal to negative 0.99. So this is this one here. Now let's look at another example. Find the area to the right of z equal to 0.76. So which means we're asking the probability that big Z here, okay, not little z, but big Z is bigger than or equal to 0.76. You know, the equal sign doesn't affect anything here, you know. And then what we have to do is, if you look at here, so it's asking the right part. As you see here, this is because Z is bigger than, so we are looking at the Z values which are bigger than 0.76, which makes this part here. And then, but our table gives, you know, this part. The table gives this part here. So what you have to do is, you should write this one here, PZ, bigger than or equal to 0.76 as 1 minus, so it's asking the right side of the right area, so you have to say the left area here, because this part is left, and it's asking the right part, so you have to say 1 minus left, so it will be 1 minus area to the left of 0.76, and how can you find this one? From the table, so you will get it from the table. So how can you get it from the table? You have 0.76. You have two components here, 0.7 and 0.06, and then 0.7, 0.06. And the corresponding number will be 0.7764. And you write it here, and then you will get the area as 0.2236. Now let's look at another example. So it says find the area under the standard curve, standard normal curve to the right of z equal to 1.06, so right of 1.06. So what does this mean? Okay, it means, okay, let me write here. So this is 1.06 is here, so it's asking the right part. So from the table, you have to find the left part. You find the left part, and then you say 1 minus the left part. So from the table, we have to find the left part now. So the area to the right is, okay, as you see here, it's asking this part here, but the table gives this part, so you find it from the table. So it's we don't show it here, but you can use it by yourself here. We found it from the table, and we subtract it from 1. So if you have difficult understanding it, please look at the previous questions, because I'm doing the about like 3 or 4 times this one now. So please check the previous examples. So this will be the answer. Now there's a question like find the area between z equal to 1.82 and z equal to negative 0.68. And here is the situation, so we have to find this one. How can you find this one? First, you look at this part here and the left of 1.82, and then you look at the left of negative 0.68, and then you subtract them. So this is how we do it. I mean, so we want to find this part, but first we have to find the area of left to z equal to 1.82. So it means this part here. And then left to the area left to z equal to negative 0.68. So we will subtract this one, this area from the big area, and then we'll get this one. So how can we get the left area? So by using the table. So we will get them by using the table here. From table. Then we'll get these values. So if you want to write the left part, the area to the left, you can write them as like probability that z is less than or equal to 1.82. And here's this part, left to negative 0.68. You can write it as the probability z less than or equal to negative 0.68. You don't have to write the equalities. It's not important. So these are coming from the table. Okay, you check the previous examples to see how to find them from the table. We already found them here, so we will get the area as 0.72173. Now, there are some questions here, and I will not solve them, but I will write the answer so you can check yourself. Try to do it by yourself, and you can compare your answers to mine. Find the area under the standard normal curve to the left of z equal to negative 0.7. You can use a table for it, and when you use the table, you will get this is 0.1423, if I'm not wrong. And here it says draw the standard normal curve and shade the area under the curve, and to the left of z equal to 1.07. So just asking you to draw it, and this is 1.07, and shade the area, it says. And if you want to find the area is, I think it's about, this area is 0.8577, I guess. Yeah, 77. Now use the standard normal table to find the area, the left of z equal to negative 1.97, and this one is, the answer is 0.0244. And for this one, if you use the table, the answer for this one is 0.9826. And let's look at them. Obtain the following probabilities for the standard normal distribution. When you use the table, you will not see -6 because when it goes to negative, when it goes to -6 here, the large values, this becomes almost, zero. This part, this area almost becomes zero, and you will not find it on the table. And I use the software in Excel. I think there's you can use Excel to find it, but it's almost zero. So indeed, what I found is basically it's 0.0.0000 about 5, something like this. And this one here, again, this 4.85. I'm not sure if it is included in the tables. Because this is a huge value, 4.85, and it's almost 1. It's about here 4.85. So this area here almost equal to 1, because this part here is almost like 0. So this has to be something. Yeah, okay. This one is again bigger than it says, so it has to be 0.000. 0.000 0.000 0.000 0.000 0.000 0.000 0.000 0.000 0.000 0.000 0.000 0.000 0.000 0.000 0.000 0.000 0.000 0.000 0.000 0.000 0.000 0.000 0.000 0.000 0.000 0.000 0.000 0.000 0.000 0.000 0.000 0.000 0.000 0.000 0.000 0.000 0.000 0.000 0.000 0.000 0.000 0.000 0.000 0.000 0.000 0.000 0.000 0.000 0.000 0.000 0.000 0.000 0.000 0.000 0.000 0.000 0.000 0.000 0.000 0.000 0.000 0.000 0.000 0.000 0.000 0.000 0.000 0.000 0.000 0.000 0.000 0.000 0.000 0.000 0.000 0.0 think it's 0 point, so it goes like this is equal to 1 minus 0.99999, and I think 6 nines, then 383. Okay, these you cannot see them in the, okay, not from the table. These are not from the table. I used Excel. These are from Excel. And these, if you have these big numbers here out of the table, they're almost like you could take them as 0 here. This one's 0, this is almost 1. I mean, this is also 0. Okay. And this one here is 0. It's the probability that z is bigger than 0 is 0.5, we know. And for this one, I found it as 0.56856 and 8, I guess, yeah. Now, please try to find them by yourself. So these are not from the table, by the way. These are from Excel. I mean, I did with Excel. You don't have to do it because these numbers are very big numbers. So when it gets bigger, you almost get 0 probability on the left side, or 1, depending on positive or negative numbers. So you can find these from the table. Now we have a different type of question here because it says find the z-score that corresponds to the cumulative area of 0.3632. So this question is a little different than the others. So because it's showing you, it gives you the area, okay, the area is 0.36. Now it's less than 0.5, so it's less than 0.5. It has to be like on the left side of center. You can say it's somewhere here. So there's a z-score corresponding to that area here. So the area, as it says, the cumulative area is 0.3632. So the question is, what is this z? So how can you find this little z here? So basically, this question is asking the z-score corresponding to an area. So now in this time, like the areas are here in the table, so you have to find the area here, and then you go back to the components of z here, and you write z. So what is z? I look at the first component, and second component, and rewrite z. Okay, we'll do exactly this question. So now we need the table here. So we'll check the area and the corresponding z. Now, as I said, you will check the area here. First, you will find the area. The area is this, and then you will find the corresponding parts of z, little z. So then, okay, little z is obviously negative 0.3, and then the second component is 0.05. So it has to be, z-score has to be negative 0.35. Now let's look at the example. Again, the same type, I guess, the same type question. Find a z-score that has 10.75% of the distribution's area to its right. So what does this mean? Okay, this means you want to find a z-score such that its right part should be should make the 10.75% of the whole data or whole distribution. So it's asking basically, it's saying that if this is little z here, it's asking area to the left is this, so what is z? So we can use a table, but the table always shows this part here. The table always shows the left part. So in this case, first you have to find the left part. So how can you find the left part? You can subtract from hundreds, or okay, we have to convert it to decimal anyway, so it has to be 1075, and then this part will be then 1 minus 0.1075, and this will give us 0.8925. So what we have to do is now okay, this left part is 0.7925. We have to go for the components of z, so we have to find these, then we write z. Okay, now, okay, let's see. Yeah, this part of the question is important for me. I mean, also, this is the most important part, because the rest all depends on the table, using the table, and you already know that. So we already found 0.8925 as I wrote before. So we check from the table. I mean, in this case, you have to check both negative part and positive part, but here, since it's bigger than 0.5, it has to be positive here. So these numbers are positive here, not the negative part. So 1.2 and 0.4 here, so z has to be 1.24. So the corresponding z-square has to be 1.24. Now we know how to find the probability on z. Okay, now we want to generalize it to a a normal distribution with any mu, with any mean and sigma. So the question is how to find the probability of x if x is a normal distribution but not standard normal distribution. Now we cannot use the table because we're not dealing with z now. So how to deal with this problem? Now the very useful property of standard normal distribution or normal distributions is this: all normal distributions can be converted into the standard normal distribution by subtracting the mean and dividing the standard deviation. So what does this mean? If x has, how do we do it? If x has a normal distribution with mean, mu, and sigma, then we can change it to z by subtracting mu from x and divide by sigma. Then in this case, this new variable z will have normal, standard normal distribution. So what is its implication to our problems? So here, for example, if you're asked to find what is the probability that x is less than k, here x has a normal distribution with mu and sigma, then this is equal to probability that z less than k minus mu divided by sigma. So here is the conversion here, the x less than k, and change x to z, how x minus mu divided by sigma, and do the same thing for k. So if you do this one, then you will get z as this one here. So instead of this, I mean, you can write here z, and this here comes here. So this is the important part here. You can change the probability question on x to the probability question on z, which is standard normal distribution. And now we can find this by table, from table. Now in the next slide we will see how to do the conversion. So we will spend some time on how to change this one to this one in different cases. Now let's do some exercises about converting from x to z. And Example, assume X has a normal distribution with this parameters. 10 is the mean and sigma is the standard deviation, which is 2. And we want to change this probability that X is bigger than 3 in terms of Z. So we want to write this probability in terms of Z. Now, let's remember what the relation between Z and X. If you remember, it was like this: X minus mu divided by sigma. Now, X bigger than 2, X bigger than 3, okay, can be written as, okay, we will apply this one here. X minus mu, what is mu here? Mu is here, sigma is here. So X minus 10 divided by 2 is bigger than, do the same thing for 3. 3 minus 10 divided by 2. And then this becomes here, this one becomes Z. Now Z is bigger than, what is this? This is negative 7 over 2. So we can say that the probability that X is bigger than 3 is equal to the probability that Z is bigger than minus 7 over 3, 7 over 2. And in the same way, we can do the other questions. Okay, let's look at this example. X has a normal distribution again with this mu and sigma. We want to write X is bigger than 3 in terms of Z-score. So again, Z is equal to X minus mu divided by sigma. Here is the mu, sigma, same. So we can write here X less than 3 and X minus 10 divided by 2 is less than 3 minus 10 divided by 2. And this time we will get Z less than negative 7 over 2. So in this case, we write the probability that X is bigger than, X is less than 3 is equal to the probability that Z is less than minus 7 over 2. So you see the difference between these two. The difference is the direction of the sign here. And let's look at another one. Now this time we have the same distribution, but this time we want to see, we want to write this probability in terms of Z, but we have two-sided inequality here. So we write it the same way, X less than 3. And then we want to change it to Z by doing this X minus mu divided by sigma. Mu is again 10, sigma is 2. And do it here, X minus 10 divided by 2. But you have to do the same thing to the left term here and right term here. And in this case, this becomes Z now. So you say this is negative 5 less than, it becomes Z now, and this becomes negative 7 over 2. So you write here that the probability that 0 is less than X and X is less than 3 is equal to the probability that Z is bigger than minus 5 and less than negative 7 over 2. Now, these exercises are important because when finding the probability, such probability, we will convert this one into Z. Then after Z, we will use a table to find the probability and the area under the curve. Okay, now let's do a word problem. A survey indicates that people use their computers an average of 2.4 years before upgrading to a new machine. The standard deviation is 0.5 year. The computer owner is selected at random. Find the probability that he or she will use it for less than 2 years before upgrading. Assume that the variable is normally distributed. Now in here, first you have to understand what is the variable. So what is the variable and what type of distribution does it have? Now the X here is, okay, so most of the time, like in the normal distribution questions, like we give you the average here and we give you a standard deviation. So, and we say it's normally distributed. So here, when you look at this information, a survey indicates that people use their computers uh, an average of 2.4 years before upgrading to a new machine. So it means, and the standard deviation is 0.5 years. So it means the X is the number of years or the amount of years. I mean, you can write it in different ways. And this is the amount of time, let's say, amount of time that um, a person uses his computer before upgrading to a new machine. Okay. Okay, before buying a new machine, new one. Okay. Now, X, I mean, here, this amount of time in years here. You can say that. So X has an average here. So X, the average of X is mu here. Okay, we will say the mean of X, the average of X is 2.4 years. And the standard deviation of X is 0.5 years. And it's assume it has a variable is normally distributed. So the X, so in this case, you can write here is X has a normal distribution with 2.4 average and 0.5 standard deviation. So after first you have to put this on the table, and then you can answer the question here. So what's the question about? Okay, so let's put this here. X has a normal distribution with 2.4 comma 0.5. Okay, X has this normally distributed, and it's the number of years before changing the machine. Find the probability that he or she will use it for less than 2 years before upgrading. So it's asking the probability that a person will use the number of years that the person will use its computer will be less than 2 years. So you have to be able to convert this question to a probability question. I mean, you should write it this way, like X less than 2 years. So what's the probability that the usage time for a computer is less than 2? So it's asking this one. Now we are given two things here. X X is a normal distribution, X is a normal distribution, and the probability of X is less than 2. So in this case, what we have to do is we change it to Z. So if you remember Z, it will be X minus 2.4 divided by 0.5 will be Z. So we do this conversion. And now by using this conversion, this Px less than 2 will be equal to the probability Z less than 2 minus 2.4 divided by 0.5, and this will be equal to the probability that Z is less than negative 0.8. So in this case, we use a table here, and by using the table, we will get, and this will be equal to, by using the table, we can get it's 0.2119. Now let's look at this question. It's again a word problem, so you have to read and understand what's given and what is wanted. A survey indicates that for each trip to the supermarket, a shopper spends an average of 45 minutes with a standard deviation of 12 minutes. So this is telling the average. Okay, this is one important thing, and then standard deviation. Okay, and the length of the time spent in the store is normally distributed and is represented by the variable X. Okay, great. So now from here you can understand from here that we have x, the variable, and this is the length of the time spent in the store by a customer. Now, and what does it say? It's normally distributed. And what is the average? It's 45, so the mean will be 45. It's the mean, and standard deviation is 12. Okay, these are given to us. If a shopper or customer enters the store, find the probability that the shopper will be in store more than 39 minutes or between 24 and 54 minutes. So basically, if you look at A, so the probability is asked. Okay, the probability asked is what's the probability that X is more than 39? And in B, the question is what's the probability that the time span is between 24, so it means X is between 24 and 54 minutes. So we want to find these two. Now, what we will do here is, okay, I will erase this one and I will do part A here and part B in the other slide. So what we know about X is X has a normal distribution with 55 and 12. So since it's normally distributed, we can change it to Z. So how can we change it to Z? We'll write here Z is bigger than. So the usual conversion is this value minus 45 mu. So let's remember Z is equal to x minus mu divided by sigma. So we have to subtract mu, which is 45 here, and sigma is 12 divided by 12. So it corresponds to the value, like the probability Z bigger than. This is, I guess it's 39 minus 46. It will be 6, negative 6 over 12, and which is, okay, the probability that Z is bigger than negative 0.5. So how can we find it? From the table. Okay, from the table. Now we have to check the table. Okay, I'm checking the table now. Okay, there's one thing is here we will use from the table. This one is the right side. If you remember, it will be right side here. So before this one, we have to write it as 1 minus the left side. So we can write this one as equal to 1 minus the left side. Now for this one, you can use the table. And if we use the table here, this part is 1 minus 0.3085. So this will be then, okay, this will be at the end, it will be 1 minus 0.3085, which is equal to 0.6915. Now let's do part B. So let's put this back again. X is normal distributed with 45 and 12. We already know it from part A. And now we want to find the probability that X is between 24 and 54. And okay, we have to change it to Z. So how can we change it to Z? We subtract 45 from all of them. Uh, 45, sorry, it has to be 45 here. I mean, no. 1 by 12. And then this automatically, this one here, even you don't have to deal with this, like you can directly say Z, but you have to do these one by one. It's 24 minus 45 makes negative 21 over 12, and this becomes 9 over 12, and we have to use the decimals here. Okay, then this becomes negative 1.75, and this becomes 0.75. Now we have to find this one. Now, as you know, this type of probability, we can do it this way. First, we write this one, z less than 0.75, minus the probability that z less than negative 1.75. So for these, we have to refer to the table. So we look at the table values for this one and for this one. Okay, for this one here, we get 0.7734 from the table. And for this part here, we will get, okay, minus, because I'm subtracting it. It will be 0.0401, and the answer will be then, the final answer will be 0.733 and 3. So this is the probability we want. So it's equal to this one.